Hi guys. So today we're going to do a lot of algebra, a lot of paper to pencil math. So just get ready. I'll warn you today there's a lot of fractions and just a lot of typical algebra. So what we're going to do to start is review some notation things that you may have seen before. Okay, so we're going to look specifically at operations, things like adding, subtracting, multiplying, and dividing. So if you were to see notation that looks like this, that's really just saying take the f of x function and add it to the g of x function. And very similar for all the rest of these. Okay, f minus g would be to subtract the two functions. F times g would be to multiply the two functions. Okay, dividing would be dividing. So you're just looking at a little bit of a different notation. So to review first, let's talk about how to evaluate a function. Okay, something we did these first few days. G of negative 1 means that you replace x in the g of x function with negative 1. So I would take that function and replace the x with negative 1. Negative 1 squared would be 1. 1 minus 5 would be negative 4. But we can replace it again with whatever is in parentheses. So in this case, we're replacing the x with x plus 2. Okay, so it's still going into the x in the g of x function. So this would become x plus 2 squared minus 5. Now, x plus 2 squared is one of the most frequently missed things with a lot of people, because what they want to do is square the individual numbers. But we actually can't do that. What we have to do is remember x plus 2 squared means x plus 2 times x plus 2. Then we can actually multiply this out and FOIL it out. So x plus 2 times x plus 2 would be x squared plus 2x plus 2x plus 4. Then we can combine our like terms and simplify this. And we get x squared plus 4x minus 1. All right, so now let's look at some of these operations. So again, f plus g of x means f of x plus g of x. So I'm just going to take those two functions and add them together. Now when I write my answer, I'll put it in standard form, which means my exponents just go in order from biggest to smallest. So this will be x squared plus 1/3 x. And then in order to combine negative 2/5 and negative 5, I need to get a common denominator. So negative 5 would be the same thing as 25 over 5. Then I can combine them into 27 over 5. All right, subtraction. Now, subtraction is another place where there's always a frequently big mistake. So this is just going to be subtracting the two functions. But you have to remember, I can't just write minus x squared minus 5, because that's not what I'm doing. I'm subtracting the entire function. So I need to put parentheses around that second function, because that's what I'm subtracting. So now I can rewrite this as minus x squared plus 5. So this would become negative x squared plus 1/3 x, negative 2/5 plus 5. Again, I'll get a common denominator, so 5 will become 25 over 5. Now I can add those two together and get 23 over 5. All right, let's look at the same functions and a few more operations. Let's look at multiplication. So I'll take these two functions, so 1/3 x minus 2/5 times x squared minus 5. And let's FOIL it out. So 1/3 x times x cubed would be 1/3 x to the third. Then minus 2/5 x squared. Then I've got minus 5/3 x. And then finally I've got plus 2/5 times 5. So that would be 2 over 5 times 5 over 1, which would be 10 over 5, which is just 2. At this point, at least, there's no like terms to combine. All right, and then division. Now you'll notice this one looks a little bit different. There isn't an x, there's actually a 2. So we're going to divide, okay? It's 1/3 x minus 2/5 over x squared minus 5. But I'm going to replace the x with 2. And then I'm going to do the math to try to simplify this. Okay, so 1/3 times 2 is 2/3. 2 squared is 4. 4 minus 5 is -1. Let's get some common denominators on those fractions. So I'll use 15. So the left fraction gets multiplied by 5. Right fraction gets multiplied by 3. So that becomes 4/15 divided by -1. So 4/15 divided by -1. All right, it's going to be a -4/15. Like I said, there's a lot of fraction practice here, but we're trying to get you guys ready because once we start trig, there's going to be a lot of fractions in that. All right, so again, let's do some more operations. F of x plus h. That means replace x in the f of x function with x plus h. Now, I know it's weird because it's more than one variable. That's okay. You'll have two variables in your answer. So this is going to be 1/3, and then I'm going to replace x with x plus h. And the original function had -2/5. Well, then from here, I'll do 1/3 x plus 1/3 h minus 2/5. There is nothing else here I can simplify, so I'm done. All right, very similar to the next one. We'll do f of x plus h. Okay, I'll go ahead and use what I just got. Okay, that's 1/3 x plus 1/3 h minus 2/5. Then I'm going to subtract the f of x function. So minus, and remember, we put this in parentheses. 1/3 x minus 2/5. All right, so when we subtract it, we're going to distribute that negative. So 1/3 x plus 1/3 h minus 2/5 minus 1/3 x plus 2/5. Then from here, let's start canceling some things out. 1/3 x and -1/3 x, -2/5 and 2/5, and all I have left is 1/3 h. So again, remember, f of x plus h means replace the x in the f of x function with what's in the parentheses. And then whenever we subtract, make sure you put parentheses around it so that you subtract the entire function. All right, this next part you probably saw for a little bit in Algebra 2. This is another operation. This one's called composition. Now, there are two different notations that you may see that mean the same thing. The way we would read this, okay, this one over here is read as g of f of x. This notation here means the same thing, okay? They both mean the same thing, but again, the way we read that is g of f of x. So this one would be f of g of 2, okay? F of g of 2. So the way we would do this is we start at the inside, and we evaluate g of 2. So to do g of 2, I take 2, and I plug it in for x in the g of x function. So g of 2 would be 3 times 2 squared. So that's 3 times 4, which is 12. Then that 12 is going to replace g of 2. So now I'm evaluating f of 12. That means take 12, plug it in for x in the f of x function. 12 plus 4 is 16. All right, let's try another one. G of f of 1. So start on the inside. F of 1 means take 1, plug it in for x in the f of x function. Then that replaces what we just found. So f of 1 is now 5. So now I'm finding g of 5. So g of 5 means take 5, plug it in for x in the g of x function. So 3 times 5 squared, that's 3 times 25, which is 75. All right, we're still doing composition, but now we're doing composition for a whole function. So f of g of x, okay? Let's see what g of x is. G of x is 3x squared. So I'm going to rewrite this as f of 3x squared. F of 3x squared means replace x in the f of x function with what's in the parentheses. So this is going to become 3x squared plus 4. Okay, because again, the g of x function replaced the x in the f of x function. Oops. All right, let's try another one. G of f of x. Okay, so g of f of x. F of x is x plus 4. So to do g of x plus 4, we replace the x in the g of x function with x plus 4. So 3 times the x gets replaced with x plus 4, and the x in the original function was squared. All right, now let's hopefully remember what we did in the very first or second example. First of all, that 3 you cannot distribute because order of operations with PEMDAS, you have to do the exponents first. So we're going to square before we multiply. And remember, x plus 4 squared is not x squared plus 16. We have to actually do x plus 4 times x plus 4. X plus 4 times x plus 4 would be x squared plus 4x plus 4x plus 16. So this is x squared plus 8x plus 16. Then we can distribute that 3 to get our final answer. All right, so that's composition. So again, you're taking one function and putting it inside another function. So this last one is the same thing we've been doing with just the same notation you guys have been seeing, just some new examples. So if you feel comfortable, pause the video, try these ones on your own. Okay, f of g of negative 5. So we'll start with g of negative 5. Take negative 5, plug it into the g of x function. So that's negative 10 plus 4, which is negative 6. Then we're doing f of negative 6. So take negative 6, plug it into the f of x function that was not labeled. Sorry about that. So that is going to be 2/3 times negative 6 minus 2. So to multiply fractions again, you multiply across the top and the bottom. So that's negative 6 over 1. So that's negative 12 over 3 minus 2. So that's negative 4 minus 2, which is negative 6. All right, g of f of 1. So f of 1 first. Take 1, plug it in for x to the f of x function. So that's 2/3 minus 2. So that's 2/3 minus common denominator, 6 over 3, which is negative 4/3. That replaces, so now we're going to evaluate g of negative 4/3. So that's 2 times negative 4/3 plus 4. So that's going to be 2 over 1 times negative 4 over 3. So that's negative 8 over 3 plus 4. We'll get a common denominator. So I'll rewrite 4 as 12 over 3. And I end up with 4/3. All right, f of g of x. So that's f of 2x plus 4. So we're going to take 2x plus 4, replace x in the f of x function. So 2/3, x gets replaced with 2x plus 4 minus 2. All right, so we'll go ahead and distribute. So that's 4/3 x plus 8/3 minus 2. Get a common denominator. 2 is going to become 6 over 3. 4/3 x plus 2/3. Told you guys lots of fractions. Really trying to get you guys ready for second semester, or mostly second semester when we do radians, which is going to be all fractions. All right, g of f of x, 2/3 x minus 2. So 2 times 2/3 x minus 2. That's replacing the x in the g of x function. Okay, so 2x plus 4, the x is now 2/3 x minus 2. So let's distribute. 4/3 x minus 4 plus 4, which is just 4/3 x. All right, then g of x. So that's g of 2x plus 4. So in the g of x function, I'm replacing the x with 2x plus 4. Okay, so the x is replaced with what's in purple, the g of x function. This one at least is nice, pretty math. So we can distribute, that's 4x plus 6 plus 4, which is 4x plus 10. All right, and the last one, f of x plus h minus f of x. So in the f of x function to start, I'm going to replace the x with x plus h. So the original function, 2/3 x minus 2, the x has become x plus h. Then I'm going to subtract, remember, the entire, in parentheses, f of x function. Now let's distribute and simplify. 2/3 x plus 2/3 h minus 2 minus 2/3 x minus negative 2 becomes plus 2. And then you'll see some things cancel out. Negative 2, positive 2, 2/3, negative 2/3, and I'm left with 2/3 h. All right, so really messy on the algebra today. Like I said, lots of fractions, but good practice. The important thing that we understand really here is the notation. So if you're struggling with the notation, make sure you come in and get some help.